Okay, now look over here. So till yesterday what we did this problem and I gave you one question, right or not? What was the question? That there was two regions of a space which was divided. Okay, there was, hey Divya, do your work. There were two regions of a space and those were divided particularly. One space was having magnetic field, one region was not having any kind of magnetic field, right or not? You are required to calculate that how much EMF is developed when this particular semicircular loop starts to rotate in that particular magnetic field, yes or no? Right or not? So this you can consider as a question and also as a concept, right or not? That whenever there is some kind of loop, okay, so I'll draw like this way. I'm just going to minimize this question, okay? So look over here. First, you have two regions. So select one region. In this region, you have inside magnetic field, the magnetic field which is going inside, right or not? Now look over here. Let's suppose this loop which you have selected has started to rotate and it has came this much inside. Okay, means this much of the part of the loop has came inside over here, right or not? Yes or no? Now try to understand. Okay, it is rotating in which way? Anti-clockwise or clockwise? Make it rotate in clockwise direction. That's better. Okay. Actually, this rotation is done in some kind of clockwise way. Right or not? Okay. So let us start rotating in clockwise direction. So if it starts to rotate in clockwise direction, how it will rotate? The loop will be like this way or not? Tell me yes or no? Or yes or no? And it will make some kind of angle theta with the vertical x-axis or y-axis, whatever you are going to consider. Yes or no? Now look over here. If you have such kind of particular angle theta, if it starts to rotate with angular velocity omega, what will develop in this loop? Some kind of current I will develop over here. How much current will be developed? You have to calculate that. Got it or not? Yes or no? So as we know, EMF is equal to what? Minus of d phi by dt. This will be equal to what? Minus of b dot dA divided by dt or not? Tell me yes or no? Or yes or no? It is going to be what? Minus of b dot dA divided by dt. Now, what is the value of dA? You have to calculate that. Tell me how much will be. So, area of this circular loop is how much? Area of this circular loop is how much? Pi r square. Yes or no? How much is the area? Pi r square. But is the pi r square always constant in this particular magnetic field? No. It's always changing. Right or not? Sometimes it is just angle theta which can be even 10 degree, then it will be 20 degree, then it will be 30 degree, then it will be 40. Similarly, it will go on increasing till again 180 degree when the semicircular loop will again come outside. Right or not? Yes or no? If this theta makes C, theta starts from here or not? Theta starts from here, and if this theta ends over here, what will happen? This semicircular will be like this way or not? Tell me yes or no? Right or not? So therefore, when the particular semicircular loop is coming out, when the particular angle, the angle over here is how much? See who is calling. Physics walla. Have you heard about physics walla? Actually, I have got selected. They are calling me. 16.5 LPA. Okay, be silent. Leave it. I'm not going. Okay, until unless you pass. Okay, so now look over here. Hey, the variation of theta, the change of theta is from where to where? From 0 degree, from 0 degree to 180 degree. Yes or no? Theta changes from 0 degree to 180 degree, and in this region, from if the theta is 0 degree, from 0 degree the magnetic field or the EMF starts to get developed. Got it or not? Why? Because area is changing over here, the flux is changing. What is happening? Flux first. Now try to understand. Can I say that flux first increases, then flux starts to decrease? Yes or no? When the particular this semicircular loop is entering inside this field, what is happening? Flux is increasing. After that, flux decreases when the semicircular loop starts to go outside or not? Yes or no? Are you able to get me or not? So when the particular flux starts to decrease, try to understand that. See, when the theta is 90 degree, what will happen? This loop will become like this way. When the theta is 180, oh sorry, when the theta is 180, this loop will become like this way, right or not? When theta is 270, the loop will become like this way. When theta is 360, the loop will come outside. Sorry. So when theta actually, when the particular loop is coming outside, wait. So try to understand. Wait, I'll write this. So when the loop is coming outside, look over here. When the loop is coming outside. So loop is coming outside when the theta is equal to how much? Theta is equal to more than, means when the theta is perfectly is equal to 360 degree, then the loop is coming outside. Yes or no? Sure. Are you able to get me or not? Sure. So from 0 to 360 means one full clockwise rotation should be there, and in that case what is happening? First flux is increasing, then the flux is decreasing. Yes or no? We are going to apply that concept and we are going to solve this. Can you just calculate that area factor? Tell me which is going to depend upon angle theta. Do it fast. Area factor which is going to depend upon angle theta. Hey, now, okay, first tell me one thing. Let's suppose if you have some kind of secant which has angle theta over here. Can you tell me the area of this secant? What is the formula of this? Area is equal to half of r square theta. What is the formula? Half of r square theta. Yes or no? Yes or no? So therefore, look over here. The amount, let's suppose the loop which has entered into this area is how much? This much is the area. So it is making angle theta over here or not? And is this length will be the radius? Yes or no? Or yes or no? Because the center, from the center this loop is rotating. So this radius, this will be your radius or not? So therefore, the flux over here is going to be how much? B into half of r square theta. So how much will be the total flux? B half of B r square theta. Now the normal of this particular loop and the magnetic field direction both are actually matching with each other. So therefore it is equal to how much? Actually, sorry, magnetic field is inside now, and the normal will be upside or not. So how much is the angle? How much is the angle? 180 degree, right or not? So here cos 180 I will use. So therefore, how much is the total flux? Half of minus of half of B square theta. So therefore, EMF is going to be how much, guys? EMF will be equal to what? Minus of d phi by dt or not? Tell me yes or no. So this will be how much? Half of B r square d theta by dt, because radius is constant or not? Sure. Or yes or no? Sure. Radius is constant or not? Sure. So therefore, how much will be the current that will be produced? EMF by what? EMF by resistance R. So this will be what? Half of B r square divided by capital R. D theta by dt is what? D theta by dt is what? Angular velocity or not? Tell me yes or no. So it is rotated with angular velocity omega. So it will be omega. So how much you got as answer of current? B r square omega by 2r. How much is the answer? B r square omega by 2r. Right or not? Yes or no? Is this correct? Hey, 1 minute. Now look over here. What it is asking, second question. Find the direction of current when the loop is entering into region 2. So how to find the direction of current? If the magnetic field is there, So current will be established like this way or not? Magnetic field is inside, but that is not the correct way now, because EMF is what? Minus of d phi by dt. Right or not? What is that? Minus of d phi by dt. So current should be actually produced opposite of the original direction of current or not? Tell me yes or no. So therefore actually current is produced in this anti-clockwise. How the current is produced? Anti-clockwise. Okay, although you know that for inside magnetic field current should be actually clockwise, but what is going to happen here? It will be anti-clockwise. Why? Because the EMF is negative of the magnetic field directions. Correct or not? Or yes or no? Okay, is this correct or not? Draw the graph between the induced current in the loop and time. Draw it. Tell me what will be the graph now. Last question of what will be the graph? Consider this to be time and this to be current I. So now look over here. Try to understand. BR square omega divided by 2R. That means what? Here, omega is a constant term, yes or no? R is a constant term. Magnetic field is also constant. 2 and radius R is also constant. Right or not? So all are over here constant. That means what? Sometimes you will get the constant current and sometimes it will be 0 or not. Tell me yes or no? Or yes or no? Why? Because this is dependent upon which thing? Magnetic field. When magnetic field will be switched off, what will happen? Current will become switched off. Got it or not? So now look over here. First, from theta is equal to 0 degree to theta is equal to pi. Is the particular magnetic field will be maximum? Yes or no? Because in this region, what will be present? Magnetic field will be present. So therefore, from theta is equal to 0 to theta is equal to pi, what is going to happen? Magnetic field will be constant and therefore current will be constant over here. After that, it will become 0 or not? Or yes or no? Yes or no? After that, what will happen? The magnetic field will become 0 in this region. From theta is equal to pi, like I'm writing in terms of theta over here. Okay, you can write in terms of, as you know, omega is equal to 2 pi by t. Got it or not? So you can write in terms of t is equal to 2 pi by omega. Got it or not? So now look over here. Till here, it will be again switched off. Then again, the current will become maximum when the magnetic field will be present, and this will be like this kind of graph. Yes or no? Yes or no? Is I'm clear or not? So this is going to be this part, this down part. Can we say that this down part will be there? Is it going to be there? Down part will be there or not? First flux increases till over here. The magnetic field, okay, means according to my suggestion, this down part should not be there, right or not? But in book they are saying that this down part is still present. Wait, look over here. Let us check. So from theta is equal to 0 to theta is equal to pi by 2. So if I write pi by 2, omega is equal to what? Theta by t. Got it or not? Yes or no? So now look over here. Omega is equal to, let's suppose if I write in terms of, let's suppose if t is equal to some kind of half of the total time period of rotation. Okay, that is t half. So omega is equal to pi. Actually, it should be like this way, right or not? Are you able to get me or not? This down should be only there. This down will be only there if I consider that till here, till from here to here the flux increases, and from here to here the flux starts to decrease. Right or not? Yes or no? Yes. When the particular circular loop is rotating over here, try to understand. See, first this loop will be like this way. Yes or no? Then the loop will be like this way. This is the particular time when the loop will have maximum flux, right or not? Yes or no? And then the loop will be again becoming like this way, and lastly it will become like this way, right or not? Yes or no? So when theta is from 0 to pi by 2, what is happening? Flux is increasing or not? Tell me yes or no? Actually theta till pi, what is happening? Flux is going to increase. From pi, what is going to happen? Flux is going to get decreased, right or not? Yes or no? Actually, it will be shown in Lenz law. According to Lenz law, they are drawing this. Okay. So first we'll complete the Lenz law and we'll draw this diagram. Got it or not? When I'll show you that what happens when the current increases and what happens when the flux increases and what will be the direction of current when the flux decreases. So there is a particular rule for it. Means you will just remind me after the class that sir, what is the rule for it when I will discuss the Lenz law. Okay. I'll discuss different types of Lenz law where you will understand what will happen if the flux increases and what will happen if the flux decreases. What will be the direction of current based upon that. Right or not? So till now you just understand that this half part will be possible. How this half is going to come over there, I'll tell you after the Lenz law. Right or not? Is it okay or not? Okay. So can I move to next part? Okay. So this is totally based upon Lenz law. Like it's increasing flux and decreasing flux. There are some rules. See, look over here. You will get to know there is some rule over here. See, look over here. What will be the direction of current when you have some kind of increasing flux or decreasing flux, which we are going to deal. Okay. Let us move to next part. Okay. Question number 3. Can you do it? What it is saying? A conducting rod AB of length L slides smoothly on two metal rails. Okay. Placed between two parallel long wire carrying current I as shown. A resistance R is connected between two ends of the rail as shown. The velocity of the velocity of the rod is kept constant by V by applying a force. Right or not? Find the induced current in the resistance by a. This is the similar question which we did earlier. Yes or no? First question, illustration 1, which we did. Yes or no? Is it similar to that or not? Do it fast then. Is it similar? Tell me. Is it similar? Tell me. Do it, do it. Okay. Something is missing over here. What is not given? What is not given in this particular case? And in first case, the magnetic field was mentioned. Here, magnetic field is not mentioned. Yes or no? That means what? This current carrying wire, this particular wire which is having some kind of current over here, this wire is going to generate some kind of clockwise magnetic field over here or not? Tell me yes or no. Or yes or no. And that magnetic field will be responsible for current in this particular rail. Yes or no? Guys, so look over here. Try to understand what is the condition that this current carrying wire, this particular current carrying wire is responsible for some kind of magnetic field over here. So this magnetic field will be again inside it. Got it or not? Yes or no? But what is the problem over here? That if you try to understand, if you have a current carrying wire like this way, if you have some kind of current carrying wire like this way, got it? This has some kind of current I. So for every increase, let's suppose, hey, sit straight. Let's suppose if I consider the points like point A, point B, point C, point D over here, at all of these points, do we have a different magnetic field or not? Tell me yes or no. How much is that? So let's suppose if this is R1, if this is R2, if this is R3. So at all of these points I have a different magnetic field, and it will be equal to how much? B is equal to mu naught by 2 pi I by R1, or mu naught by 2 pi I by mu naught I by 2 pi R2, something like that will appear or not? Tell me yes or no. So can we say that magnetic field starts to decrease when you move away from the current carrying wire? Yes or no? So that means what? To do this kind of problem, to understand that how much magnetic field is present over here in this region, got it or not? How much magnetic field is present over here? Actually, it is not constant. This magnetic field is now not constant. What is happening? For the end A, means for this particular rod, what is going to happen? The magnetic field will be maximum, but for this particular end, the magnetic field will be actually minimum. Got it or not? Yes or no? So actually, to calculate that how much magnetic field is affecting from A to B, you have to consider one element over here or not? Tell me yes or no. Yes or no? How to solve this kind of problem? First consider one element. Let us consider one element over here. Let's suppose this element, this particular element has some kind of width. How much? Consider the width of this element to be equal to dx. Yes or no? Then you will have to consider that this element is located from the current carrying wire at a distance x or not. Tell me yes or no. Guys, yes or no? And then you will have to calculate the amount of magnetic field which is affecting over here. Got it or not? To calculate the magnetic field, which is going to be how much? Mu naught by 2 pi I by x. Yes or no? Guys, what's the problem? Up. It will be mu naught I by 2 pi x or not? Yes or no? Sir. Okay. Now, based upon this, can you calculate the EMF? Do the EMF calculation now. Do it. Do it. Can you calculate the particular flux over here? Flux is what? B dot dA. Yes or no? Now, what is this length? X or not? You are aware. Okay, this length is X given over here. Okay, consider it to be. We'll have to consider it to be different variable. Got it or not? Let us consider it to be R, and this is dr and this is R. Okay. So this is going to be R. Now phi is equal to what? B dot dA. Yes or no? Now here in this region, for this particular current element, in this region, how much is the flux present over here? It will be the magnetic field which is present over here, which is equal to mu naught I by 2 pi R. Actually it is d phi which is present. A smaller flux is present into what is the area? Area is how much? It is breadth into length. Yes or no? Sure. So it is x into R. Sorry. X into dr, because we are calculating for a smaller length. Got it or not? Sir. Yes or no? Yes, sir. Now, if I know the d phi, so in this smaller length we calculated our flux. In this particular smaller width we calculated our flux. If we integrate from this A to A plus L, means this gap is how much? A. This is L. So if I integrate it from A to A plus L, can I get the total flux or not? Yes or no? So total flux of the system will be how much? Calculate it. Total flux of the system will be how much? Integral A to A plus L mu naught I by 2 pi R dot x dot dr. Got it or not? Yes or no? So how much I get? Mu naught I by 2 pi R. Sorry, 2 pi mu naught I x by 2 pi, and this is going to be what? Log of R. Yes or no? Log of R from A to A plus L. How much I got as phi? Mu naught I x by 2 pi log A plus L divided by A. Got it or not? Sir. This is the total flux in the system. Yes or no? Sir. Is I am correct or not? Sir. So now what it is asking? It is asking about the current. Current is what? 1 by resistance d phi by dt or not? Sir. 1 by resistance d phi by dt. So 1 by R. Now look over here. What is varying when we can do d phi by dt? Actually flux is varying due to movement of this railroad or not? Tell me yes or no. Look over here. See this. This particular AB is moving with some kind of velocity. Due to that only what is happening? The flux is going to vary. Yes or no? So that means what? Which variable is your varying? X variable is going to vary. Got it or not? So therefore, I should be equal to what? 1 by R. What is d phi by dt? It is equal to mu naught I by 2 pi dx by dt, which is going to vary with respect to time, into log A plus L divided by A. Got it or not? So therefore, how much is the total current that is produced? 1 by R mu naught I by 2 pi. What is dx by dt? Velocity of the rod, yes or no? Into log A plus L divided by A. Got it or not? Is it clear or not? Do it fast. Came sir today class again. I'm going to take come over here. Okay. Hey, Harshita, where is your circular motion notes? Harshita, Shreya, Rakshita, where is circular motion notes? Take it from today. Today, just give me right now after this class, okay? Can I move ahead? Hey, what doubt? Tell me. Tell me. Do the next question. Question number 4. Hey, a rectangular loop. Hey, a rectangular loop of n turns, an area A and resistance R rotates with angular velocity omega about y-axis. Got it or not? The loop lies in uniform magnetic field B in the direction of x-axis, assuming that at t is equal to 0. The plane of the loop is normal to the lines of force. Find the expression for the peak value of EMF and the current induced in the loop. What is the magnitude of torque required on the loop to keep it moving with constant velocity omega? Do it. Draw the diagrams first. Okay, look over here. Look over here. Sir, I'm taking the class in second PUC, sir. Hello? 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 Do it first. 2 minutes. Do not talk. SM, do this problem. Hello, sir. I'm taking the class in second POC. POC. Your sound is not audible to me. Hello? 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 What? Okay. We'll do it later. Do this question. After this question, what it is saying that there is a rectangular loop of n turns and area and resistance r. Right or not? How it is rotating? It is rotating with angular velocity omega. So let us consider make the axes now. Okay. Hey, over here. So is this is my particular y-axis, right or not? This is x and this is z. So what it is doing? The rectangular loop of n turns and resistance r rotates with angular velocity omega about the y-axis. How it is rotating? It is rotating like this way. Got it or not? About the y-axis. Yes or no? Now what is happening? The loop lies in a uniform magnetic field B in the direction of x-axis. Where is the direction of magnetic field? Towards the x-axis. Got it or not? The direction of magnetic field is towards this side. Okay. Now what it is saying, assuming that at t is equal to 0, the plane of the loop lies normal to the lines of force. Okay. If it is lying normal to the lines of force means what? The n cap, the particular n cap of this particular rectangular loop will make 0 degree with the particular magnetic field or not? Tell me yes or no. Miran sir, I'm taking the class in first POC. Hello. Second POC. Actually, my phone has a problem. Okay. Just do this question. Okay. Now look over here. So, can you calculate the flux out of it? How much is that going to be? Now look over here. If this rotates with angular velocity omega, what will happen? Is the normal is always going to change or not? It will start making angle theta with the magnetic field or not? Yes or no? And this theta will be equal to how much? This theta will be equal to omega into time t. Yes or no? Guys, are you able to get me or not? Yes. So therefore, flux will be how much? N number of turns into magnetic field into area is going to be how much? Area A is given into what? Cos theta, which is equal to cos omega. Got it or not? Yes. So EMF, the particular EMF that will be developed will be how much? Minus of NBA into omega into sine omega t, and this will become positive or not, because the differentiation of cos omega t is negative. So did you got your EMF? So what it is asking, what is the peak value of EMF it is asking. So is it going to be NBA omega or not? Tell me yes or no. So I denoted it by E naught. What I denote? I denote it by E naught over here. So E naught means what? It is the peak value of EMF. Got it or not? Is I clear or not? Let me check with the answer. Yes. So your answer is BAN omega sine omega t. Got it or not? So therefore the maximum value of EMF is what? BA omega n. Got it or not? Now look over here. What it is asking? Second question. It is asking the peak value of current also. Current is what? Current is EMF by resistance or not? It is current is EMF by resistance or not? So how much will be the total value of current? NBA omega by R into sine omega t. So how much will be the maximum current value? It will be also this only or not? Tell me yes or no. That is going to be NBA omega by R. Yes or no? Is that clear or not? Okay. Now what is the question that is asking? What is the magnitude of torque required on the loop to keep it moving with constant omega? Now tell me that. What will be the answer of that? Tell me. Tell me what will be that? Now here comes the biggest concept. How to calculate the torque which is required to make it rotate with angular velocity omega. What will be that? Initially at t is equal to 0. What was the total flux from the system? Maximum. Yes or no? Then it starts to decrease because cos theta decreases after time. Yes or no? And then, so what is the meaning of that? That initially, do you require some kind of force to rotate it or not? Eh? Initially, do you require some kind of force to rotate it or not? So now look over here. There are torque is what? Torque is equal to force into radius. But work done is equal to also force into displacement or not? Tell me yes or no? Or yes or no? Yes. So here in a magnetic field, I can relate this. I can relate this particular thing with a very good way. Look over here. We know that power input is what? It is equal to force dot velocity or not? Tell me yes or no? Or yes or no? So if this velocity has came how? It has came by force d by dt of displacement s or not? Tell me yes or no? But if it starts to rotate with angular velocity omega, this displacement will change into angle theta or not? Or yes or no? Yes. So now look over here. So try to understand. If I consider with in case of rotation, what I can write? I can write force dot this d by dt, and this displacement will change to what? R into angle theta. Got it or not? Got it or not? Because arc length it will consider or not. How much is this displacement? R into theta or not? Tell me some arc length. So therefore, what will be this? F into R d theta by dt. F into R is what? torque or not? Tell me yes or no. So what you got as power input, if you consider in terms of torque, it is equal to torque into omega. Remember this formula. What is the formula of power in terms of torque and angular velocity? Torque into omega. Got it or not?
Sir.
Or yes or no?
Sir.
Now, if this loop is having some kind of resistance R, so in previous question, what you observed in this question number 1, that the mechanical work was responsible for heat dissipated in the system or not, and the power which you apply by mechanical work, that whole power was getting converted into heat energy, yes or no? So here also, what will happen? This particular power which you apply, it will convert into heat energy or not? Tell me yes or no. So power is how much? Tau into omega. Heat energy will be what? I square into power. Rate of heat dissipated will be what? I square into R. Right or not? So therefore tau into omega is equal to I square R. You apply this formula, and did you get the torque or not? Tell me yes or no. Because you are aware of omega, you are aware of this current I. How much is this current? NBA omega by R sin omega t, and you will get that. Easy peasy? Yes or no? Yes or no?
Sir.
This was a new formula or not?
Sir.
New derivation? Write this. Write this first. Acha, Chandra. Where is Pari, Chandra? Uh-huh. Ah, it's the brain of Thanush. Chandra is
Gamer.
Heman.
No.
Ah,
He's like a gamer. YouTube gamer. He's gaming.
okay. Chandra. Hey, Chandra. Hey.
He's a gamer.
Do you support Chandra, yaar? Tell him how to do the thing. Do you wanna? Hey. Okay, guys. 1 minute.